So today we are going to cover another type of data structure, that is the double linked list. We are already covered the single linked list in previous video. So first we have to know what is a double linked list. So double linked list is a variation of the linked list in which navigation is possible both the ways. Either it can be forward way or it can be a backward, means both the way we can perform traversing, means either it can be backward or it can be a forward. And it is very easy compared to the single linked list. Single linked list, what happened? We can move forward, we cannot move the backward. And this is the example of the double linked list. So double linked list means a node consists of three things. First one is the data itself, the information we want to store. And there are two pointer. First point to one pointer point to the next node. So this is the another node. Node address is 200. So it store the 200 address. So one pointer store the address of next node, and one more pointer is there which is stored the address of back node. So in this case, double linked list means the structure is declared in this way. So this is the structure node. Structure info means data we are going to store. There are two pointer. Next pointer is used to store the address of next node, and back pointer is used to store the address of previous node or back of the existing node. So this is our first node, second node, third node, fourth node. So this list consists of four node. First node data is 10, and start pointer point to the first node. So start store the value of 100 and points to this one. Reason is that the first node address is 100, second node address is 200, third node address is 300, fourth node is the 400. So this is the first node present inside our double linked list. First node's backside, there is no element present inside that. That's why the back pointer of the first node store the null value. Middle one is the information, and here the information is 10. This is the next pointer. Next pointer store which value? Address of next node. So this is the address of next. So this is our second node. Second node, this is the back pointer. This is the next pointer. This is the information. Back pointer means it stores the address of previous node. Now address of previous node is 100. So it stores the address of previous node. So the connection is established. This is the information it stored. Then this is the next node. Next node store the address of next node. Now in this case, next node address is 300. So it store the address of 300. Similarly, this is the third node. This is the address of previous. So previous node address 200, it store the 200 address. This is the information part. This is the address of next node. Next node address is 400. This one. This is the last node of our linked list, double linked list. So this is the back pointer. Back pointer store at address of previous node. Previous address is 300. This is the information. This is the null, because the last node, there is no next node is present. That's why it store the value of null. And last store the address of 400. So this is, there are two pointer, start pointer as well as the last pointer. In my program, I always try to put the two pointer. Reason is that I don't want to traverse all the node whenever we are going to perform any operation with the last node. Either insert in the last node or delete in the last node. Any operation we want to perform last node, unnecessary we have to traverse start node to the last node. That's why I always put two pointer. One pointer points to the first node and another pointer is the last point to the last node. So this is the my logic to put. So this is the structure declaration for the node in case of C language, because we are going to implement in the C language. So structure node consists of three elements. First one is the information and remaining two pointer. This pointer next is point to the next node. Back is point to the back node. Next we have to know what are the operation is performed by the double linked list. Same as the single linked list, but different way. Insertion, same here. Insertion at beginning of the double linked list, inserting at the end of the, or any specific position. Deletion also deleting and from the begin of the or end or specific position. Then we have to traverse the linked list. Then searching an element is present or not. Remaining other operations is there, but these are the minimum operation we have to perform. Searching and updating, then find out the minimum value or maximum value. There are so many operations we can perform, but minimum thing is inserting, deleting, traversing, searching. So let us start the insert at begin of a double linked list as well as how to display it. So whenever we go for display double links, we can move forward as well as we can move the backward because there are two pointer, one pointer for forward move, another pointer is backward move. That's why we can print the value in forward way or we can print the backward way. So inserting at the begin of the double link. So first there are two cases. First case is that memory allocation is not possible. So we have to print the error and exist. Whenever we go for the memory allocation, that is the malloc function, there is a chances memory is not available. It's very rare chances, but chances is there. That's why we have to go for the case one. Otherwise, means memory allocation is done. When memory allocation is, then there are two cases. First case, list is empty. Then if our list is empty, means there is no element present inside the double linked list. Then what we have to do? We have to let newly created node as a PTR by help of the malloc function. So this is our malloc function. So this is our malloc function. Then what happened? We have to allocate the memory and the memory address is 100 for successfully memory allocation is done. Then what happened? So first we have to make the PTR, then store the data into information part. How it can be possible? PTR info equal to num. So information we store the 10 value. Here we store the value of 10. After that what we have to do? Make the back and next pointer of newly created node as a null. Why? Because it is a only single node right now. So there is no node previous. So this is a only one node is going to be stored in the double link. So both the side, there is no previous, there is no next node. So both the side we have to store as a null value. So now we store the value null. Once we store the value, then now point the start at last pointer to the newly created node. So how we can make it? Start equal to last equal to PTR. Means whatever PTR address we have to store inside the post, the start pointer as well as the last pointer. Previous, the start and last both store the value of null because we whenever there is no data is stored, as it is a pointer, we have to store the value of start as well as the last pointer as a null. So once the one node is created, then as it is a single node, that's why both the start as well as last point to the first node. So right now our double linked list is completed. Only single node, both the pointer points to the null, start points to this node as well as so start and last store the value of 100. So this is the first case when the list was empty. Now list have elements, right? Right now list have the element, only one element. It may be one or two, but it has elements. Then let newly created node as a PTR. So we create a node PTR. So this is a node is created PTR and the node address is 200. Store the data into information part, that is 30. So num store the value of 30. So it means we are declare a variable num and num is going to be stored the whatever value we enter from the end user. Then as insertion in first position, because we are going to insert in the first position into the linked list, make the back pointer into newly created as a null because it is first pointer is this node is going to first means first there is no previous node. So this node means this back part we have to store as a null value. So we store the null value because there is no previous node because this node is going to be first node of the linked list. So first node of the linked list means there is no previous. So simple we have to store the null value. Then make the next pointer of newly created node as a start node. Previously, this node as a start node, right now it's going to insert the first node. It means that this node, next part is point to this node. So we have to store PTR next equal to start this value. Means if we store the 100, means connection is established. So We store the 100 and connection is established. Then make the back pointer of start node to newly created node. Previously, what happened? Start node is null because there is no data. It is just start node. Right now, it's going to be first node after the second start node. So that's why we have to make the start back. This back is we have to make a connection. So this is 200. We have to store 200. Once we store that connection is established. So now we store the 200 and the connection is established to this one. Then now make the start as a newly created node. So right now connection is established, data is stored. So now we have to make this start as a this pointer. So now we have to make now start point to this one. So now this is start node. This is the second node. So our double linked list is over. So insertion in the first position. This is the algorithm we have to follow. Then we have to, once we perform the insertion, then we have to know how to display. So display means there is a same two cases. List has no element. If list is empty, then what we have to make? We have to print error message and there is no data to display. Second case, list have elements. So as it is a double linked list, so there are two pointers, so we can move forward as well as we can move the backward. So if we go for forward direction, store the address value of the start pointer into the temp pointer, then print the information stored inside the temp, that is the temp info. Then move the next pointer of the node temp, then continue step 2 and 3 until we reach the null. That is the end of list. This is for forward. If we want to go for backward, then what happened? We have to store the temp pointer value of the last because we are backward traversing. Then print the information stored inside the temp info, move the previous node by help of the temp equal to temp back. Here we have to perform temp equal to temp next. Here we have to perform temp equal to temp back. Then same, continue the step 2 and 3 until we have done reach the end. So this is the way we can able to do it. So let's take an simple example how we are performing. For example, this is our double linked list. Only 3 element is present. For example, so this is our start. This is our last. So 10, 20, 30. 100 address, this is the 200 address, this is 300 address of the node. So last store or value of 300, start store of the 100 address. So connection established. This one is the null value. Then this store the address of 200. So connection is established. This store the previous address, that is 100. So connection established. This node store the address of next node. This node previous value, that is 200. So connection established. This is null. So this is, for example, our double linked list. So now we have to go for forward direction. So if we go for forward direction, then what happened? Store the address value of start pointer as a temp pointer. So now we have to do temp store which value? 100, because it is start is 100. We are moving forward direction. Forward direction means this way we want to print. So print the information stored and the info. Now we have to print the value. So this is 10 we print. Then move temp equal to temp next. So what is temp next size now? 200. 200 until we did, so null. 200 is not equal to null. Then what happened? We have to print 200 info, that is 20. Then 200 next, that is 300. 300 is not equal to null means we have to continue. Then what happened? 300. 300 next equal to null. So we have to stop here. So stop here means we are, what is the information? Information here, sorry, the information is 20 because this is the 20 value. So information is 20. So what? Forward direction data is 10, 20, 30. So forward value is 10, 20, 30. Next one, backward direction. So if we go for backward direction, then what happened? Temp store the value of last pointer. So what is the temp value? Temp value is 300. So now temp store the value of 300. Print the information stored inside the temp. How we print temp info? Temp info is 30. So what information it's going to print? 30. Move to the previous node of the temp. So we have to move to the temp to the previous node. How? Temp equal to temp back. So this is our temp. 300. Temp back is 200. So now this is 200. Then we have to print the value. So print the value means we have to print 20. Then 200 back. 200. This is 200. 200 back is 100. So it will move to the 100. Then we have to print the value 10. Then this is 100. 100 back is null. So now it is null. So if it is null means we have to stop because this is the end of the list. So now if we traverse the backward direction, what is the value? 30, 20, 10. So 30, 20, 10. So this is the way we can able to print the double linked list. So let's start the implementation by help of the C language. Now we have to go to implement of the our algorithm for the insert into the first position as well as the display. First, we have to include the header file stdio.h for printf scanf. As we have to go for malloc function, so we have to include library function also stdio library function. First, we have to define the structures. Node. Here I use the type depth. Reason is that I don't have to write down the struct keyword always. Just if I have to write down only the node and I can able to access all the data. So this is the first is information we want to store. So info here I declare the variable for store the data as a info. Then node star next. Restore the address of next node. Then node star back. Back is to store the address of previous node. So this is the declaration is over. There are two pointer we require. First pointer is the start pointer to the start to the first node. Last pointer last to the last. So we have to define initialize the start pointer as a null because there is no element stored inside the data at time of in starting of a program. So we have to declare start and as well as the last equal to null. So, so if we understand the details of the single linked list, then double linked list is easy. So in this video, in description section, I put the details of the single linked list. So once you cover the single linked list, then it is easy. So we declare two pointer start and last as a null and we store the value. Then we have to define the function. So the function name is the insert begin or in first it is our choice whatever we want. So this function does not take any parameter, does not return any value. Okay. So here this is the algorithm. Memory allocation is not possible. So we have to first there are two cases. Case one, memory allocation not possible, we have to print error. Otherwise, memory allocation is possible. So first we have to go for memory allocation. So we have to write down structure star nodes. For example, we store inside the PTR, newly created as a PTR. So we make the name as a PTR. So here we go for malloc function. First we have to go for memory allocation. Depend upon the size, the memory allocation is done. Once done, we have to check whether memory allocation done or not. If PTR equal to null means memory allocation is not done. Then what we have to do? we have to print error, or we can write down memory allocation is not done. So after that, we don't have to do anything. We have to just print and so else means memory allocation is done. So if the memory allocation is done, then what happened? Remaining things we have to perform. What are the things we have to perform? First, store the data into information part. So we have to store the information part. So we have to store the data means we have to read the data. Once we read the data, we have to store. So printf new line, enter the element into or double linked list, because we are going for double, so we have to write down doubly linked list. Or we have to enter within the one tab we can go for example, after one tab we have to enter the value. So once then we have to scan value, scanf %d. So where we have to store, for example, we store inside the num. So we have to store num. Before that, we are not till now declare what is num. So we have to go for declaration of num. So here we have to declare integer num. Once we declare, then what we have to do? Make the back and next pointer of newly created node as a null. Means both. How? Print next equal to null, print back. Okay. Okay. PTR next. Next equal to null. Next pointer null because it is a after that we have to here one thing is, if list is empty, then only we have to make the null. So this two statement is common for all, so we are just make these two statement. After that, what happened? If the list is empty, if the list is empty means if start equal to null. If start equal to null means list is empty. So this is list is empty. If the list is empty, then what we have to do? Make the pointer. So PTR, because it is only the single element, so we have to make the PTR equal next equal to null. PTR back equal to null. Only one element is going to be created. Once it's done, then now the make the start pointer as a last. So right now what happened? List is empty. So this PTR becomes the single node in the linked list. So single node means start and as well as the last both points to the same node. So start equal to last equal to PTR. PTR is the newly created node. So this is the case is over. Else means what? List have elements. If the list have elements, what are the things we have to do? This two is common. We are already done. Then insert the first position of linked list, that is a position of the linked list back pointer newly created. So whatever the newly created node is going to be the first node. So first node means first node back is always null. So PTR back equal to null because it's going to be the first node. Then next of new node created to the, because this newly created node becomes to the first. So first node means it points to the next, it next points to the currently start. So PTR next equal to start. After that, make the back pointer of start to null. Okay, right now what happened? We have to make the start pointer to connect to null pointer. So back equal to PTR, that is the newly created node. Then we have to make the start as a newly created node, that is ptr. So this is the all about function for the insert an element at begin. So once the both cases, that is the start equal to null means empty list. After that, if the both the statement is done, then we have to write down insertion is successful. Then we have to write down insertion is completed. So this is our program right now. So this is till now we are already done the we are completed the after that I think one ending parenthesis is required for the starting. Yes, completed. So our insert at begin is completed. Right now we have to go for next we have to write down that is display function. We are already completed the insert at beginning. So this is our void display. So now we have, so what is the algorithm? This is the algorithm is written left hand side. That is, we have to check whether the list is empty or not. So how to check the list is empty? So here we if start equal to null. If start equal to null, it means that there is no element. So we have to write down printf. So let us start the display function. So display function does not take any parameter, does not return any value. So this is our algorithm. First, we have to, there are two cases. Case one, if list is empty or list have elements. So let's take the first case, that is the list is empty. How to know the list is empty? If the start equal to null, then list empty. If the list is empty, then what happened? We have to print the message. Printf. So list is empty. Else, if list is not empty, store the starting pointer into the temporary pointers. So here what happened? This is for forward case. So we have to write down printf new line, that is elements inside list as forward moving. It is our choice which way we want to format our things. It is not mandatory that we have to follow this way. Then next line. So next line, what we have to write down? We have to store the start address into another pointer. So we make the node start temp as a start. So we store the start address. Then we have to start the print. So what we have to do? Printf. How to display all the elements we are covered in our starting videos. So you can follow this one. Start Then while temp not equal to null. If temp is not equal to null, then we have to print. What we have to print? This is a forward direction. Both the direction possible. So we have to write down in this way. So this is the bidirectional symbol, %d, then temp info. Because in info part we store the data. So once it's done, then what we have to? We have to put the semicolon. Then temp equal to temp next. We have to move to the next node. That's why we have to go for temp equal to temp next. So temp equal to temp next. So this condition is over. So this is our forward direction is over. So after that we have to write down the end. So we have to write down printf. What is null? So this is our forward direction is over. Once forward direction is over, then we have to go for the backward direction. So for backward direction, what we have to write down? Printf. Then we have to write down printf start. Then we have to store temp equal to last node value because we are traversing right now backward. Then while while temp is not equal to null, what we have to do? We have to print the value. Printf as it is a bidirection, then what we have to do? Bidirection symbol, then %d, then temp info. Then temp equal to here what happened? We have to back to the previous node. So temp equal to temp back. Once it's over, then we have to print the end printf, that is here also instead of null we can write down the starting or end. It is our choice which way we want to print our data. That is the starting node. This is the end also start. Here is also instead of null we can write down and it is our choice. It's the starting. This is the ending of the linked list. It is purely depend upon our choice how we want to print our output screen. There is no hard and fast rule. So this is our display function is over. Now we have to go to the details of the program. This is end means this. Okay, okay. Expect. This is for else part. Display part is over. So right now insert is over, display is over. So in this program, I will go for the menu drive program. One by one function we just go to add because this the thing it is easy. Whenever we go for the linked list, there are so many operations. So it is better we should go for the menu drive program. Yeah. So first I have to make a choice because each and every time we have to enter the choice, then we have to go for printf. So this is our double linked list. It will print output screen. It is our choice how we want to put our output screen. After that, two new line will be created. Then it will ask our chess. Printf, that is new line. So one for insert at begin. Right now only two options, insert and display. One by one we'll add all the things, but right now it is for insert at begin, then display, then 3 is for exit. Okay, whatever we enter we have to scanf. Scanf %d, then ampersand choice. So now we can make this one in a do while loop. So for example, I make this one is a do. So this is first. It will ask the whatever we enter, it will continue according to that. Whatever choice we have to put into the switch case. Choice. So choice case one. So we have to call the function. In last video, that is Q, we told that before that if you put any clear screen, then the whatever operation it will be clear, then it will go for the CR. So first we clear the screen, then only we call the function. So it will clear the screen, then only it go for the insert and beginning, then break. Then case 2. So it is display. Then we go for the break. Then case 3, that is case 3 is for what? For exit. We can write down exit 0 also, it can be possible. Or we can write down the, it is exit point. It is our choice. Whatever we want, we can write down here. Exit point. Then break. Then we can go for break. Then default. Then default case is printf invalid option. This is our, after that, this is the switch case is over. This is switch case. After that, what happened? This is for do while. So here, while choice is not equal to 3. Why 3? In our previous video, we are already explained all the things. Also, I put the link of the video in the description section. You can go through it. Let's compile the program. Printf. Okay. Clear screen, we have to include the conio.h header file. Because the clear screen function is present inside the conio.header file. That's why still then we are getting error message. Yes. Even though we are enter the conio, this header file under the conio, still we are getting error message. I think it may be not working in my system because actually what happened, whenever we are using the software, it is not that much original. We are just downloaded and maybe due to that it's not working. But anyway, without that also we can do it. Let's see. There is no error. Okay, good. Then let us compile once again the program. Okay, there is no error. So we have to run the program. Oh God, it's showing only one line. After display, we are not put the new line. That's why it is not one by one. Okay, anyway. For example, you go for enter the data. So first data I enter 11, then I go for display. What happened? It's not showing the address. Okay, let's see. First, we have to rectify this portion. Why the format is coming like this? Let us rectify this one. This is the main program. Okay, new line. Then display that after new line exit. Then also it will be new line. After that, we enter a choice. Okay, let compile and run the program. Okay, one, we are for go for insertion 11. Then one, we go for 22. Then three, exit point. So this is working. For example, we want to go for insert the data, but I want to go for display. Yes, list is empty. There is no element. So I go for 11. Then I go for 20. Then I want to go for display. If we go for display, start, forward, backward, but it's not showing some other value. Okay, okay. So if display, so it's going good. Let's see in our display. Okay. Backward direction, make a new line. Okay, then go to the insert begin now ptr means null is then else it is scanf none if equal to null. So it stored the info. Here we did a mistake that we are not stored the information. That's why it took the garbage value and stored the value garbage value info equal to none. So here we have to store the information part. Then only the output will be display information part. Okay, let's see whether we are getting the answer without. 1, enter the value 1, let's display 1. Start 11, then immediately end. Okay, this symbol is not present inside the okay. Okay, let we have to rectify the display also. Not rectification, just modification. Display we are getting the result, but only not the format. Okay, this is after end. If we make 2 line, then it will be looks good. So now we have to insert the element we are inserted. Now we have go for display. So element inside the list, that is 33. Okay, as we are performing insert in the first position, na, so first 11, then 22, then 30. Forward moving, yes, forward backward direction. Double linked list, that is the 11, 22, 33. Yes, we are getting the correct. Right now we are got the correct result. So this is the exit point. So this is the way whenever you're writing a program, we convert the algorithm to the implementation phase, but there is a chances that we may do some mistakes, and after that you have to check and you try to rectify the error. Hope you are able to know how to write a program and then how to add all the things. So this is our menu drive program. Here only one case to one by one we are going to add all the. So this is our complete program. This is our matlab, updated program. We are already rectify all the error and perform the operation. We are already got the correct results. So here what happened? We declare two pointer start and last, and we store the value, that is null value. So here we declare two pointer, that is start and last. Both store the value of null, that is the initialization from the last PPT. Right now we are going to insert a value. So here what happened? We declare a num is a variable. Then node star ptr malloc. So what happened? Memory allocation is done. So right now one memory allocation is done, and that memory allocation name is as ptr. For example, address is 500. If ptr equal to null, no. In this case, we are already got the memory, so this is not true. Memory allocation is done, so it will go to the else part. Printf, enter the number into the or element into the linked list. Whatever we enter is stored in that the num. For example, I enter the value 50. So ptr info store the num value. So there are three part. We are already know the structure declaration. What this is for back, this is for next, this is for info. So info store the num value. If start equal to null, that is the case of empty list. Right now it is true. Our start is null, then ptr next equal to null. So this is null. Sorry, this is no, this is backside. So this is not. So first we have to store the ptr next equal to null. So here we store the value of null. Then ptr back. So this is the back. We store the value of null. Then start equal to last equal to ptr. So ptr value first we have to store the last. So what is the ptr value? 500. Now last value right now assigned to the start, that is 500. So whenever it is 500, both the pointer points to this one. It means that this is a single node. This node is treated as a starting node as well as the last node. So for example, we compile up the program once again and we want to insert a value. So again we will go for insert. So now ptr memory allocation. For example, now the memory allocation is 100. ptr equal to null, no, else part, enter the element into the double linked list. For example, I enter the value 10. So ptr info. So right now it is ptr because here whatever function it returns store the ptr value. So ptr info store which value? 10 value. If start equal to null, no, right now start equal to 500 means already data is present, so it will go to the this part. ptr back equal to null. ptr back equal to null. ptr next equal to start. What is the start value? Start is 500. So it store the 500 means connection, forward connection is established. Start back equal to ptr. So what is ptr value? ptr is 100. So right now start back. Which one is the start back? This one. Previous store the which value? Null value. Right now This stores the 100 value. So it stores the 100 value. So connection established to this one. Now start equal to PTR means whatever PTR value. What is the PTR value? 500. Right? Previously, what is the start value? 500. Now PTR start store which value? 100 value. So if it stores the 100 value, then what happened? Now it stores the value of 100. So 100 means now point to this one. So right now insert at begin is over or not. So this is the way insertion operation is going to be performed. So let us consider the display function and how the display function is going to perform its operation. So for example, this is the double linked list information is with us. For example, this is the first node, then this is the second node, this is the third node, 1, 2, 3 data is present. This is the last node. This is the start. So 100, 200, 300 are the corresponding the address of node. So it start last store the 300, start store the 100 address. So this store the 200. This is 100. This is 300. This is 200. This is null. This is null. So this is our linked list is present. We have to print the information. So printing means we can print 1, 2, 3 or 3, 2, 1 because the both way the movement is possible. That's why we can print the double linked list either forward direction or backward direction. So if start equal to null, so this is the condition is for the empty list. Else means data is present. So this is the case right now, and so output will be displayed. That is the element inside the list forward direction. So after that, temp store which value? Start value. So now temp store which value? 100. So printf start. So the output will be display start while temp not equal to null. Yes, it is true. If it is true, then this symbol it will print. Then what it will print? Temp info. What is temp? 100. Where is the 100? 100. What is the information part 1? So it will print 1. Then go to the, then temp equal to temp next. Temp is 100. 100 next is 200. Right now temp is 200. Ending curly bracket, go to starting curly bracket. Temp is not equal to null. Yes, it is true. If it is true, the body of the loop is going to be executed. What is the body of the loop? This one. Then temp info. What is temp right now? 200. 200 information is what? 2. Then temp equal to temp next. 200 next is 300. So it will store which value? 300. Ending curly bracket, go to starting curly bracket. Temp is not equal to null. Yes, it is true because it is 300 right now. If it is true, then body of the loop is executed. So what is the body of the loop? This one. Percent D temp info. What is temp? 300. 300 info is 3. So it will print the value of 3. Then temp equal to temp next. 300 next is null. Right now the value is null. So while temp not equal to null, now this condition is false. So this loop is not executed. After that, what happened? Next line will be executed. What is the next line? This symbol and so this is our forward direction printing over. Now we have to go for backward. So backward means two lines. So two line is created. Then it will display backward direction double linked list. So this one. Then it will print which value? Start. So this is for backward. Now temp store which value? Null value. Previously the temp store which value? Null value. Right now temp equal to last. What is the last value? 300. So temp store which value? 300. While temp not equal to null. So 300 is not equal to null. Yes, it is true. If it is true, printf this symbol, then temp info. What is 300 info? 300 info 3. Then starting, then temp equal to temp back. 300 is the temp. What is the 300 back? 200. So it store the which value? 200. Then go to the starting curly bracket and then 200. 200 is not equal to null. Yes, it is true. If it is true, then what happened? Body of the while loop is going to be executed. What is the body? This symbol. Then percent %d, temp info. What is temp? 200. 200 info 2. So it will print the 2 value. Then temp equal to temp back. What is temp? 200. 200 back. Which value store? 100. So it will go to starting curly bracket, that is temp equal to temp back. So 200 back is 100. Now it will go to the, is it the 100 is not equal to null? Yes, it is true. If it is true, the body of the loop is executed. What is the body loop? This symbol, then percent %d. What is the percent %d? Temp info. What is temp? 100. What is 100 info? 1. So it will print the 1. Then temp equal to temp back. 100 back is null. So right now, what is the temp value? Null. While temp not equal. Now this is false. If this false, then what happened? Next line will be executed. What is the next line? This symbol and end. So this symbol and end. So this is the data in backward direction. So this is the way display function execute. In case of double linked list, we can print forward direction, we can print the backward direction. So this is our main function. In main function, there are three cases. Case 1 for insert, case 2 for display, case 3 for print, then default value. So hope you are able to understand the concept of double linked list, how to insert at the beginning of the list and how to display. Thanks for watching the video. Please subscribe the channel, like the channel as well as share the channel.